So at ConceptBio, we enable growers to harness the potential of the plant microbiome for their crops. Between now and 2050, it's estimated that we're going to lose something like 25% of agricultural output in the world because of climate change. In a world where we already use far too much land and far too much water just to keep up with current demand in a population that is continuing to grow. One of the best solutions that's come about to keep growing in a world where climate is making it harder and harder to grow, as we have been, are greenhouses, particularly high-tech hydroponic greenhouses. The advantage of these systems is that you get 10 or more times the yield per unit area that you get from traditional agriculture. You use a fraction of the water that you normally use because it doesn't drain away into the soil. You can recirculate it. It's very, very climate resilient. You're growing indoors, so obviously it matters a lot less what the climate is doing. You can keep growing year-round. And because of that, it's already a very large $100 billion market, growing very quickly, expected to be about $265 billion by 2030. Now, the challenge is that plants, like human beings, have a microbiome. We human beings, we rely on a community of microbes inside us that's vitally important for our health, and plants have the same thing. So my PhD at Oxford was studying how plants will recruit microbes from the soil around them in order for them to grow properly. The problem is, in hydroponics, plants are grown in a nutrient solution. There is no soil. That's the definition of hydroponics. And so there's a lot of beneficial microbes that plants expect to find around them that are just missing in these systems. And that creates enormous untapped potential in terms of yield, disease resistance, but even the quality and taste of these products. It's just not being used by these growers. So what we've done at ConceptBio is we've collected the world's largest database of plant microbiome data for hydroponics. We've built ML models from that and from that DNA data and used it to identify beneficial microbes specifically targeted for hydroponic systems to try and put back some of these microbes that are missing. We've been able to collect over 11,000 samples from more than 30 growers around the world. We've used it to identify our first beneficial microbe product. We've been sending it out to growers since the start of this year, and they've been reporting to us about a 9.8% improvement in yield across more than 14 trials. And this is an industry where I've personally been shouted at more than once by growers when I've said, I think we can do a 10% improvement in yield. And more than half of the hydroponic lettuce market in the US has already asked to trial our product. Thank you.
If I understood correctly, we can still hear you. So
testing? Aha.
Yes. So all the
That's
way
a long
back.
throw.
Okay, I'm gonna need some help here.
Raise your hand again.
There we go.
What species does it work with? Is it species specific, your product? Does it only work with lettuce? Does it work across a wide range of
It's
crops?
been most extensively tested on lettuce. It's also worked on beetroot. And we've got a cucumber trial right now that's reporting about an 8% improvement in the number of cucumbers coming off each crop. That's all it's been tested on so far.
So you don't need any species specific fine tuning?
I think it makes sense to get a different microbe for each crop, but there's usually cross-activity, right? It doesn't just work for lettuce, it will work for other crops as well, especially in a system like this.
Thanks.
Great, so maybe we can see even multi-crop systems in the hydroponics soon. That would be wonderful. Well, thank you so much,
Thanks.
Paul. I'm going to take that back and hand it over to Jean for the next picture.
Yes, thanks a lot, Paul.